All right, good morning. I'd like to go over the bell work with y'all today. And what I want to do is I want to kind of read through it and just point out a couple of things. So first of all, it's giving you KP, not the KC. So in this one it says at 900 degrees, the KP is 1.04 for the following reaction. Now when I look at this reaction, guys, you see how this is a solid, this is a solid, and this is the gas. All right, so that's going to come into play in just a few minutes. All right, the next thing it says is at low temperature, dry ice, calcium oxide and calcium carbonate are introduced into a 50-liter reaction chamber. The temperature is raised to 900 degrees Celsius, resulting in the dry ice converting over to the gaseous CO2. For the following mixtures, it says, will the initial amount of the calcium oxide increase, decrease, or remain constant? So what we're really looking at is what's going to happen to my reactants, because I only have one reactant. So what I want to do is I first want to just simply address this just like we did in yesterday's class, and I would like to write out the KP. So the KP is going to be the pressure of my products compared to the pressure of my reactants, and in this case I only have one of my products that come into play. So actually my KP is equal to the CO2's pressure. So it would be this over the reactants raised to their concentration, but these are solids, so nothing actually comes into play except that CO2. So knowing that, I can just go through and do my number line, and I can put, all right, I know that my KP is 1.04. Now, in the first example here, they tell me that my KP, not the KP, but the pressure of the CO2 is 2.55. So in order for that to go back to equilibrium and to reach, I'm going to have to move in that direction, which tells me my reactants are going to be favored. So if the reactants are going to be favored, then the calcium carbonate is going to increase, and I'm going to go ahead and do the other one. The calcium oxide is going to decrease. And the calcium oxide is here, carbonate here, so this one would be consumed as it went that away. All right, let's look at the next one. And on this one, same thing, except this one says that I have 1.04, and my actual is 1.04 for the pressure of the carbon dioxide. So since they're the same, then it is at equilibrium. So if it's at equilibrium, then all the concentrations remain constant. They are not going to be changed. So you can tell that if we are traveling toward the reactants will be favored, therefore they'll be going up, therefore the products would have to be consumed, therefore they would be going down. Okay, I hope that this helped show you just the relationship between these two. All right, y'all have a good day.